Hello, everyone. Thanks for hopping on today's TAP session. For anyone new, TAP stands for Trusted Advisor Program. It's hosted by the Cisco Philadelphia Select team, where we bring the latest and greatest from Cisco. There's just way too much tech out there to keep tabs on, and so our goal is to break down what's new, what's relevant, and what's going to make a difference for you and your business. Today, we're going to be diving into an AI update with Erik Sklba. And Erik, I'll let you go ahead and introduce yourself.
Thanks, Eric. I actually have a slide for that as soon as we get rolling. So
Floor is yours.
floor is mine. So I'm going to put on share mode here. Let me try to do that correctly here. There we go. All right, thumbs up if we're good to go here.
Good to go.
Oh, well, yeah, just real quick before we get started, for any questions that any of the attendees might have, just go ahead and post those in chat, and then we'll answer them the best we can, either through chat or we'll interrupt Erik and ask him live. So just want to share that with everyone. Sorry, Erik.
Yeah, appreciate that, Ron. That's good stuff. So first of all, thank you for taking time out of your Friday morning to meet with Cisco and listen to what we're doing in the AI space. We're going to cover a portion of the AI portfolio today. We've got just a ton of exciting innovations and announcements. There's so many, we won't get to them all today. We've got 45 minutes to an hour approximately. So there's just a lot going on. Today we're going to talk a little bit about what Cisco is doing from the compute network, monitoring, visibility, observability, and security space. That's a lot to cover in an hour. We'll even talk a little bit about the recently announced Cisco NVIDIA partnership and what that might mean to you, or means to us for sure. And hopefully we answer some questions. The point of this is to give you a little bit of a high level. We're able to go deep on any of this, but from a time perspective, we can't. We want to give you a high level sort of taste of what Cisco's doing and why we're doing it from an AI perspective. But this is sort of step one, right? You have account teams, you have resources experts, you have partner community who can deliver this message more tailored to your needs at any time. So this is to give you a flyer with follow-up expectations. So who am I? That's me. That is not an AI generated picture. It's just old. I've been at Cisco for 17 years now. So I started as an engineer. I worked as a specialist from a data center perspective. Both of those were about 8 years each. And then for the last year, I've been an AI specialist covering what Cisco considers commercial accounts for the East. An AI specialist at Cisco is a relatively new role. As the world turns and as ChatGPT sort of made AI incredibly important, Cisco decided that we needed a layer of expertise to be able to communicate what we're doing in the AI space, not just from a product perspective, but more from a why. How do we solve for use cases? How do our products fit into the use case conversations? How do we get in front of the line of the business and help to understand how to solve these problems with our technology? So that's what I do. And like I said, I cover commercial East, and that includes the Philadelphia area. So any of the accounts on this call or any of the partner community on this call, you'll be able to get to me through your account teams. And I have a group of about 200 AI specialists at Cisco, and I have a couple of engineers directly assigned to me, and we can go as deep into your use case as needed. So why are we here today? Right. So Cisco doesn't make GPUs and everybody thinks of AI. They think of GPUs and NVIDIA. Well, all those GPUs have to work somewhere and connect somehow. All of that peripheral equipment is in our portfolio. Now, in order to do AI, you essentially have to have a differentiated environment with differentiated security, visibility, and control in order to successfully accommodate what your AI use case looks like. Here's a little quote from our boss. This is really the fundamental justification of why I even have this job and why we decided to invest in an AI specialist team. So I like to put it up there to kind of remind myself of why I'm here. So we've made huge investments in product development, in personnel development, through acquisitions and investments as angel investors and into the entire technology community. And this really highlights the importance that Cisco puts on an artificial intelligence and the promise of what it can bring to bear. So if you've seen me talk before, you probably know that I cover this this sort of three-tiered approach of why even AI is a conversational piece. Most companies are using AI to either save money or increase, productivity, or make money or reduce risk. But we've all heard, how big of a market it is, but there's concerns, right? Will AI outpace our ability to build supporting infrastructure? Can AI eventually self-optimize its own infrastructure for efficiencies? Is AI going to be able to enhance cybersecurity, or will AI-driven attacks create a new arms race and network defense? How are geopolitical AI regulations going to impact global competitiveness? Will people shift to accommodate changes that AI brings? Right. Ultimately, AI is redefining what's possible from the save money, make money, reduce risk perspective, but those questions remain. So from a save money, make it very simple. Like if you're looking to save money using AI, this is things like workforce management, onboarding and schedule optimizations, right? Logistics stuff, predictive maintenance, anything like that, automating of like repetitive tasks, that sort of thing. Making money with AI, that's really, by the way, saving money is sort of phase one. That's where most companies are starting. They want to kick the tires a little bit, do a test drive with AI. You're going to do this in a way to not impact the core function of your business. Impacting the core function of your business is the make money category. You want to make sure that AI works for you before you put it in play to monetize or really grow your business. So you want to understand how you can use AI from a simple perspective. Reducing risk. This is stuff like compliance and security requirements, keeping the reputation of your company intact, but also things like automated incident responses, fraud detection if you're financial, market risk analysis, disease prevention if you're in healthcare through predictive like diagnostics and that sort of thing. So none of this comes without a challenge. Everybody's got skill gaps, risk and compliance issues to be aware of, security issues to be aware of, the legal landscape, data security, sustainability might be an initiative at your company and you have to concern yourself with this. The complexity of AI modeling and how to do these use cases in support of AI. Most AI projects fail. About 80% of AI projects fail out the door. Some companies like the fail fast model, figure out if it works. If it doesn't, move on, try to fix it, do something else. But about 80% fail. And it's because it's a complicated environment and we may not be quite tooled up. So what can Cisco offer in support of your AI initiatives? We have a comprehensive portfolio. We've taken these considerations and challenges and initiatives kept them in mind in our product development. And what I'm going to do throughout the next about 45 minutes or so is talk to you about what Cisco's doing from each of the individual component perspective. But remember that the intention here is for this stuff to be cohesive, right? All of this stuff needs to work well together to provide a platform that supports your AI initiatives, as well as the visibility and control to support your AI workloads. So we do this through sort of a generically defined unified approach to AI. Our unified approach to AI includes infrastructure, it includes security, software and tooling, third-party components where we don't have products, things like storage, for example. We're not a storage company, even though we offer some measure of storage capabilities through things like hyperconverge and that sort of thing. We don't have storage from an AI perspective. So where your data lands and lives is not likely a Cisco product, but we partner with those companies to ensure that when we build a solution, we take how those things work into consideration. We give a lot of flexibility throughout the AI landscape to allow you to right size your environment specifically for the needs of what you have. So you're going to see a lot of variety in these product groupings, but that variety is important because right sizing for AI is key to being successful, because this stuff is expensive, not only from a cost perspective, but also from a power consumption, space, time. All of those things are important. So as we go into our compute portfolio, this is compute for AI. For those of you who may be unfamiliar, UCS is our compute catalog of products. As we go into there, I'm going to pause for half a second, see if we've got any questions yet.
We're good right now.
All right. So this is an incredibly busy slide. I want, as you look at this, I want you to sort of look at that. We've got a server family that can support a variety of needs. Everything on that left with the light blue header, the mainstream enterprise servers, these are just servers. For the most part, they're just servers that you would use for whatever your need for a server might be. An x86 server, a virtualized instance, a variety of workloads, hyper-converged deployments. We support Intel and AMD from a CPU perspective. I like to think of this as a Swiss Army knife. So you right size your server needs for whatever you're trying to accommodate. And most companies have a variety of different types of services for servers for different use cases. We also support GPUs in these servers. And historically, that's because you'd maybe want to run VDI, and VDI uses GPU. But you can repurpose these servers also by incorporating GPUs into them, or even using your algorithm on a compute-based perspective to support AI workloads. Those modular systems, they can mix and match, right? If you look at the top left, that's a UCS X series. It's a modular system, formerly known as like Blade servers. That's a grouping of 8 independent slots for independent servers or independent nodes, independent hosts. You can populate that from a Swiss Army knife perspective to have a virtualized server, a bare metal server next to it, potentially a 3-cluster hyper-converged instance, and then maybe even AI in the same chassis. You can do a lot of different things with this toolkit, and we're going to see a little bit more on the X series shortly when it comes to AI. Now, the AI specific portfolio is on the right-hand side. Those are purpose built for AI. We're going to talk about all of this stuff in a little bit more detail. I just want to give you an idea of what the catalog looks like. So you're essentially going to size appropriate to what your needs might be. On the far left, those are those AI specific servers. We call those the Cisco UCS C885 Alpha M8 and the 845 Alpha M8. There's no test, right? Don't worry about the SKUs, but we have purpose-built servers that are specific to dense GPU AI deployments. We'll talk about where those fit relative to different AI needs. In the middle there, under the UCS Blade and rack perspective, this is just standard Blade / modular servers as well as rack-based servers. That's almost the entirety of that left-hand catalog. Why is it here in the 8i portfolio? Is because we can purpose build these to support AI workloads. And I'll talk to you about what that looks like from an AI pod perspective in a slide coming up. And then on the bottom right there, here's a sneak peek of what we're going to announce at Cisco Live US. This is an edge box. This is an AI at the edge solution that incorporates network storage, compute, and some security functionality into it. I am giving you this heads up that this is coming, but I am not going into detail on this today. However, if you have a specific need for information on that, reach out to your account team and we can dive right in. So let's start with the 885 Alpha M8. This is the big platform. This is based on NVIDIA's reference architecture for an HGX platform. And what is an HGX? HGX is essentially the OEM version of a DGX. These boxes are built to support 8 GPUs, one-to-one map to NICs, usually a CX7 400 gig NIC or Bluefield DPU, in support of if it's NVIDIA, probably a rail optimized environment, or AMD GPUs, maybe a fat tree type of environment. The purpose of this is to maximize performance of each individual GPU of the 8 GPU in the box. And the GPU on the box itself, there's 8 of them. They're connected to each other via NVLink. So this is a protocol that's a different protocol than, say, PCIe, which allows for connectivity of all the GPUs to each other. Think of it simultaneously. Instead of having one connection point from each GPU to connect to, each GPU connects to all the other GPUs simultaneously. This is purpose-built for network connectivity that's RDMA based. And, it's the, thanks, Eric. This is where you're going to find GPU farms. This is customers who look at HGX-based platforms don't usually buy one. They buy clusters and build out machine learning environments or AI environments that are larger, because you're spreading an AI workload across multiple GPUs, high-performing GPUs, and you're maximizing the performance of the individual GPU to process your algorithms. The other specific to AI platform is the 845. Now, you'll see that this is called Mustang. That's the internal code name. And I'm not going to lie here, I just stole this slide, and that's why it's white and it doesn't look like the other backgrounds. I just snapshotted a picture of somebody else's version of it. It has an internal name Mustang. Code name for the previous server is Bronco. For one reason or another, we went with Ford names, and I'm not sure why, or horses, either way. But this is an MGX system. So the previous system was an HGX. HGX and MGX are different use case specific. Now, in HGX, I mentioned, had 8 GPU. Each of those GPUs is individually connected to a NIC, and those NICs connect to other devices one-to-one, usually for rail optimized environments or networks, or fat tree environments with AMD deployments. In the case of a Mustang, or in the case of a MGX, which is also an NVIDIA reference architecture, you basically grow this system in groups of 2 GPU, 2, 4, 8 GPU, up to 8. But what you're doing is you're tying 2 GPU together with NVLink, and then connecting those 2 GPU to the other GPU via PCIe backbone. So the purpose here of why you would tie 2 GPU together is to extend or increase the GPU memory size, right? So instead of having a single GPU performing as a single GPU, you connect 2 together with NVLink, and you increase the memory size, which allows you to have differentiated algorithms and differentiated use cases, because you have a larger memory table on a per GPU grouping perspective. You can do different things with this device. So this is a 4U system. The previous system, the 885, was an 8U system. And again, these are purpose-built for AI workloads.
So Eric, there's a question, I think you just touched on it, but is the interlinking technology the bus that connects all of the GPUs and NVIDIA technology, or is that within the Cisco chassis?
So connecting the 2 GPU to each other, these are, think of it, you're going to populate with like an H100-NVL GPU. That would provide NVLink connectivity from GPU 1 to GPU 2, okay? But now GPU 1 and 2 are now paired. In order to connect to GPU 3 and 4, if you're spreading an algorithm or spreading an iteration of a workload across multiples, now that's a PCIe board. That's on the motherboard. That's a Cisco box scenario. And that's the way the reference architecture for MGX is written by NVIDIA. Cisco is not the only vendor who has an HGX-based platform or an MGX-based platform. We might be the only one that has both, but this is a reference design from NVIDIA to allow for a platform to increase the performance capabilities of their GPU family.
Thank you.
Does that check the box on the answer?
Yes.
Okay, fantastic. Okay. 885 and 845 are AI specific. That's where you're going to position these. You're not going to use these as x86 based servers. You're not going to use them as a virtualized server or anything like that. You're not going to do VDI here. These are big boxes for AI and ML. Where you might use um, a multi-function solution would be an AI pod. Now, what's an AI pod? You probably heard this from many vendors. Everybody's got an AI pod. It's a coin term from NVIDIA as well. So an AI pod, the idea here is to provide sort of a solution that includes multiple aspects of AI. So obviously, if you look to the compute perspective, you're going to have a server. You may have some connectivity. You may have some services and support. You might have a hypervisor layer. In this case, we support OpenShift. You might have some software, some tooling. We do this as a bundle. Okay. So the idea here is you can bundle out hardware, connectivity, software, all through single SKU, and you can include services, you can include visibility, you can include all kinds of different things. It's an AI pod, right? Orderable, validated, ready to go out the door. What do our AI pods look like? They look like this. I know there's a lot of words here. I don't expect anybody to read this, but what I can tell you about AI pods is this. We have 4 different sized AI pods. And if you look down here, you're going to see that these are the modular servers, the X series servers that I showed earlier. What we're doing here is we're populating these modular chassis with a compute node and a GPU node. And then we're layering on NVAIE software to give you the hardware and the software in the single chassis. But you'll also notice that there may or may not be open slots in this chassis. So in the case of this edge inferencing node that I'm highlighting here, you'll see that there are 1, 2, 3 slots filled. These are power supplies over here. But you'll also see 1, 2, 3, 4, 5 blank panels. There's no rule saying I can't use those blank panels for something else. So I have the flexibility of doing AI and other stuff in the same chassis. That other stuff could be, I might have maybe I'll use these 3 open slots for a hyperconverged cluster. Maybe I'll use these 2 slots for just standard servers if I choose to, just standard x86 virtualized servers, something like that, or I can leave them blank, right? So that means that I can go to market by either expanding an existing X series domain by adding in a couple of nodes and software, or I can bring this independent and have extra slots to be able to do different things. So I got a lot of flexibility here. What I'm not showing specifically is that there's flexibility in the builds themselves, right? So it's not specifically that I have to have one L40S GPU. There's other options here. This is a flexible device. The platform, the hardware platform itself for an AI pod is obviously you got to have the server, you got to have the host, and you generally have to have the software, which includes NVAIE. Now, NVIDIA's AI enterprise software, I'm going to talk just briefly about in a moment. You could, if you're so inclined, use open source modeling and essentially just get some hardware and go to Hugging Face and pull down models and different things and do your own AI. You can do that too, right? We're not locking you down to having to use NVAIE. But for this to be an AI pod, supported as an AI pod through TAC, you're going to have NVAIE, which means if you call TAC and you have a problem with your software stack or your hardware or something that you're not able to figure out, TAC will work with you to solve the problem across, in this case, a multi-vendor environment. OpenShift is optional for those customers who are maybe looking for Kubernetes alternative container management instead of, say, VMware. And then add-ons include things like various storage options here. So NVAIE, NVIDIA's AI enterprise software. So this is a software stack. Think of it like a bundle, and that bundle includes basically everything a customer would need in order to do an AI use case. In fact, they publish blueprints, they publish all kinds of information to help customers navigate those environments. So if I'm using an example here, which I am, of maybe I want to build a retrieval augmented generation pipeline. Perhaps what I need to do is, if I'm on my own trying to go open source, I got to figure out what I need from a model perspective, how I want to build this. But if I use NVAIE, I can go follow the blueprint of build an enterprise RAG pipeline. I can see that here are maybe the models I need. And there's all kinds of information that I'm not showing here that's included, including downloadable executables to actually do this use case. But one of the things I'll find is that I have a minimum system requirement from a hardware perspective. So to do this RAG example and support these models, if I'm going to go Docker or Kubernetes, I'll probably need either 6 H100s or 9 H100s, giving me some idea of how to size for this use case. I'm going to go back a slide to show why we've built these as RAG, large RAG, scale outs, edge inferencing. So in the case of the large scale RAG inferencing use case, we've built this, as you can see, where's my mouse? There it is, with 4 H100 GPUs. So that kind of gives you an idea of the thought process behind why these are sized, and there are 4 appropriately sized. We are building out more and more AI pods just to kind of give, I hesitate to use the word like recipe or cookie cutter, but ultimately a starting point for you to solve for various use cases. AI, typically you're going to start with, what's my use case? What am I trying to do? And then you're going to back your way into what do I need to do? What do I need from a hardware perspective to support that use case? So that's the thought process here.
There's a question, a couple of them, but is there any trade-offs when it comes to hosting multiple functions on the same chassis? Example, AI performance reduction. And do you have the ability to throttle different functionality to maximize performance?
Read the question one more time to make sure I understand what's being asked.
Are there any trade-offs when it comes to hosting multiple functions on the same chassis?
Okay, let's stop there for a moment. So can I assume that question, if I'm assuming this question correctly, if I'm hearing it correctly, they're asking whether if I use these other spaces for something else, am I losing performance or trade-off? Is that correct?
I believe so, yes.
Okay, so the answer to that is no, because each of these is independent. Each of these slots is an independent, completely independent server. Now, I will tell you that for today, at least, the X series caps out at 100 gig connectivity. So you're not going to be able to run 400 gig here or anything like that. So CX7 is not a capability yet. CX8, obviously not yet, because it's not real yet. So you're not going to run 400 gig here. However, you're going to have multiple 100 gigs. You're not even going to have a oversubscription from a traffic perspective. And with Intersight and the control functionality through historically what's been considered like UCS Manager, being able to build prioritization and controls into even failovers and that sort of thing, you're going to have some control in how you might stand this up. But these are independent slots so that if you're running something else in this same chassis, they're completely independent. In fact, these servers and GPU nodes, they don't even connect to a backplane like we used to do with what we called the UCS B series chassis, where there was a mid plane and these servers all connected to a mid plane and it was a shared host or shared bus. These connect directly to what's called the IFM, or the input output modularity. So they're independent of each other. Read the second part of the question, Eric.
You answered everything.
Okay.
Yeah.
Okay. If that didn't answer it correctly, or for clarification, whoever wrote that can come back into it, and we'll see if we can solve that conundrum. Okay, so that sort of winds up the compute portion of what we wanted to talk about today. Are we okay? Do we have any compute questions before we move on to network? Anything else? All right,
We're good.
All right. so network, right? It's really important to understand why an AI ML network is different than a traditional, like, just data center network. You got to understand sort of how AI ML works. So for the most part, when we're talking about an AI ML network, right? And I want you to think about what I said from a compute perspective. We had those two servers that were AI specific, and then a bunch of other servers that can support AI. I'm focusing this information a little bit more on the AI specific environment, right? Which would generally have a cluster beyond a single node of servers, right? So more than one Cisco 885 Alpha, right? Two or three or four, or a bunch of hosting a bunch of GPUs working in a collective. So the way that this works, right? Once you have more than one host, more than a GPU, you got to connect them across a network, obviously. The way that the algorithms for AI work is they're incredibly computationally intensive, and they perform calculations across very, very large data sets. Those data sets are too large to fit in a single GPU's memory. Even in, like, the case of the 845, where you have an expanded memory by tying two GPU together, these data sets are bigger than that even. So what happens is you split the job across multiple GPUs to distribute the load. And the cluster would perform an iterative set of calculations on that data set. So in other words, each GPU is performing a smaller portion of the overall iterative calculation, but they're all doing this simultaneously. And as they do their iterative calculation, they're sharing the results to all the other GPUs in the cluster. So remember in school when you were learning algebra and you were like, when the hell am I ever going to use algebra again? I'm just going to have you visualize this formula, like parentheses 2 plus 2, end parentheses, second set of parentheses, 2 plus 2, end parentheses. You know that you're going to calculate each of the 2 plus 2s before you calculate the parentheses aspect of that formula. I know that's probably a terrible visual, but it's just the way it's going to be, because it's off the cuff here. So what's happening is these GPUs are sharing the results of 2 plus 2 and 2 plus 2. So everybody knows that that's 4 times 4. But you got to do the 2 plus 2 portion of the calculation first. That's a very generic way to say how GPUs are working. But after the transmission of the result of that initial calculation, there's what's called a barrier operation. And that barrier operation stalls the GPU while it waits for the results of those calculations. Now, if you're doing this across multiple hosts, you gotta go across the network. So the barrier operation makes the entire process sensitive to the performance of the network. So if there's one slow path in the network, all the GPUs are stalled waiting for that transmission to complete. If there's dropped packets and those results are not received, everybody's stalled, and then sooner or later there'll be a timeout and that job will not complete. Any suboptimal path will stall the entire AI ML job. Basically, the reason for this slide is to indicate how important the network is to GPU performance in AI ML in general. So what's incredibly important here? These parameters: latency, network loss, bandwidth, load balancing, visibility, all of these terms are really important to understand, because the performance of the network, we tune the network using we'll call it RoCE or ROCE, RDMA over Converged Ethernet, because essentially RDMA is the GPUs communicating to each other in what looks and presents as a lossless environment. Now, Ethernet is a lossy protocol. So we have to configure the network in support of lossless traffic flows, because a loss in network traffic means that those GPUs are going to stall and eventually the job's going to not complete, and therefore your use cases is going to fail. So we tune the network, and we do so in support of RDMA over Converged Ethernet, which is not new and it's not Cisco proprietary. RDMA over Converged Ethernet or RoCE has been around for 30 years. It's been around forever, very, very long time. But what's now important to understand is Ethernet has basically surpassed InfiniBand from a bandwidth perspective. InfiniBand being lossless, very much like Fiber Channel, the protocol. But now Ethernet can perform as if it's lossless through tuning, and we can do so today at 800 gig, which is incredibly fast. And by the way, we're about a year away from 1.6 terabytes per port, and then probably 2 years from 3.2. Cisco has already started developing those platforms, and we're already taping out the A64 1.6. Again, still a year away, and a year for Cisco means probably 16 months. But it's just me saying that. So
Love
right.
that slide, by the way.
This slide here.
Yeah, I love that. I'm gonna have to grab that from you.
Yeah, no problem. So you'll see some of these terms, right? For those of you who are techie, you'll see PFC and ECN and scheduled fabrics and all kinds of different things that we do. And these are just features. You turn these features on to enable these performance metrics to present an Ethernet network as if it's lossless. Now, you can also run in an Ethernet network other traffic simultaneous to AI. Maybe in an AI farm, a GPU farm, you're not going to do that, but you may tune your network to prioritize the AI traffic while also still supporting, print server traffic or whatever, email, right? You deprioritize that. If that stuff fails, who cares? It'll retransmit. If AI stuff fails, and it doesn't show as lossless, that job might fail, and however long that calculation's expected to take, starting over at some point.
Question: how would you set up queuing in the network?
Queuing. Okay. So let me come back. So PFC and ECN are both queuing mechanisms. So all of this sort of falls into that QoS class of service conversation. So what you're basically doing is you're prioritizing flows either port to port or end to end. And those prioritizations will create, think of it like pumping the brakes or a little bit of back pressure. So any network, you have send and receive, right? So something is sending traffic, something is receiving traffic, right? And you got a pipe between the two. And if the sender is sending too much information, especially in the case of multiple sends to a single spot, sooner or later, the receiver, the destination, is going to be overwhelmed, and it will start filling up buffers, and those buffers start dropping packets. So what we do is we have buffer visibility, and we start monitoring those buffers, and we define limits in those buffers to say, okay, at this point, I need the sender to slow down. So you're sending back a back message to the sender to say, slow down your transmission. You're overwhelming my buffers. And once my buffers get to a certain point, I'm going to start dropping packets. I'd rather have a slower transmission than dropping packets. So what we're doing is creating back pressure. And this, by the way, is not a Cisco thing. There's a PFC ECN, it's not Cisco. So we're essentially defining those buffer parameters and doing pushbacks. There's other things you can do, like dynamic load balancing and static pinning and all kinds of different things to configure your environment in support of not dropping traffic. But the easiest way to answer this is we're prioritizing based on class of service, quality of service, and DSCP type of markings to identify those AI flows, prioritize them, and ensure that we manage the receiving buffers to not drop those packets. Is that the answer?
Yes.
You guys are making me dust it off. I used to have those certifications back in the day. They may have expired. I don't know. So I mentioned flexibility and choice. From an AI perspective, we've got basically 3 things to choose from. I'm going to start with the middle, the Cisco 8000, because we're not really going to talk about this much, but I just want people to be aware that we have it. So hyperscalers, they use Sonic. If you're not familiar what Sonic is, it's an operating system. So it is it's not a common operating system in the enterprise. So for most customers that are not hyperscalers, nobody's really doing much with Sonic. We are a contributor to Sonic. It's a community supported OS, and we have a entire switch family based on Sonic that hyperscalers do purchase and use, but we don't see a lot of that in the enterprise. So I'm exposing you to the idea that we have it, but not digging deep into it. Wow, Erik, you got to give me a heads up, man. We're 47 minutes in. We're only on the second thing. All right, so let me cruise here a little bit. We may only get through compute and network today.
That's fine.
Okay, so
it's better that we be able to get through the technology like this and kind of go through it, because so often when we go into meetings, we're pressed on time as well, and so we don't actually get to have any of these like deeper discussions. So that's exactly what the forum is for, is so that we're not having to go over everything. So if you don't finish everything, oh well.
Let's go. All right. So on the left, you'll see the Cisco Nexus 9000 family. This is a family of switches. This is what we commonly see throughout our most of our customer base. This is also the switch you might see from an NXOS or an ACI, software-defined management perspective. In AI, you're generally not going to see ACI. You're generally going to go with independently managed switches. This is our most common platform. And then most recently, we've got something called Hyperfabric. I'm going to cover Nexus 9K and Hyperfabric here, and that may be where we're at. So the newest version of the Nexus 9K family is a 9364 Echo. Echo indicates that this is an 800 gig switch. So 64 ports. 93, by the way, is the fixed form factor Nexus 9K. 64 is the port indicator, meaning I've got 64 ports, and E means 800 gig. There's a D version for 400 gig. There's a C version that runs 100 gig, right? So as we iterate, you're probably going to see the F version is going to be the 1.6 terabyte switch in a year or so. This is 800 gig ports. So today, customers who are doing GPU farms might be looking at this to do 2x400 breakouts, to do individual connectivity to CX7 NICs or something like that.
Oh, you're good. I'm just answering the question.
That's all right. No problem. It's a 51.2 terabyte with 100 gig SerDes switch with a 256 meg fully shared packet buffer. The packet buffer note that I'm talking about is important because of the idea of that queued buffer filling up with once you start getting a port to be overwhelmed, that buffer starts to fill up. That 256 megabyte buffer is shared across all 64 ports, and that's the buffer that we would use and monitor to give our pushbacks. We do this in 2 form factors, which is the QSFP and the OSFP form factor. QSFP is more performant. Hyperscalers have looked at OSFP, and customers in this space are starting to think that OSFP might be the way to go because the adoption at the hyperscaler might drive optics costs down. We'll see. We have both. does either or, so it's your choice. It's not it's one or the other though. It's not a configuration. The optics socket is unique for each. Hyperfabric. This is our software as a service stateless designed network topology. Now, what you would do here is the concept of having a cloud controller to give you the ability to design your environment, to order your switches based on what your design looks like, to build your configuration, and to deploy through a cloud controller. And then these switches are essentially stateless hosts. You connect them up, you'll see even like lights telling you what where you plug in your optics and that sort of thing. And it's a plug and play cloud serviced model. So some of our customers like the idea of the flexibility to be able to deploy a network from a screen and then have smart hands install it somewhere else, right? And not have to do individual switch configurations, but rather have a topology based configuration. We take that a step further with Hyperfabric for AI by allowing the cloud controller access into third-party components, things like the CX7 NICs and the GPUs and storage entities. So from the cloud controller, being able to expand out your configuration of a topology specific to an AI workload, inclusive of the software, NVIE software, the operational models, visibility into the full stack across the board for AI. I'll note that there are caveats with this, and one of the caveats is these switches are not something you can repurpose, and it's a subscription model. So in other words, you're going to have a very low investment for the hardware, but you're going to subscribe to the Hyperfabric software. And if you decide in a year or two that this isn't for you and you want to take that hardware and do something else with it, you can't. It's a brick. But that's just the way the model is. But we're talking, these switches are like $5,000, so they're pretty low cost devices. It's the software where the cost actually comes in. Okay, I think we have time for just a little bit more. For those of you who are historical Cisco customers, first of all, thank you. And secondly, I'm sure you're familiar with the Cisco validated design process. This is where we publish validated designs that look like either recipe books or blueprints, and they include third-party stuff, right? So we have published AI ML blueprints that include basically a how-to configure an environment. So if you were looking to figure out like, well, how do I configure my network to support Rocky? Well, here's a blueprint that'll walk you through it. How do I connect storage, and how do I connect these different devices, or how do I deliver this service with whatever it might be? You can go to Cisco's CVD repository and find a blueprint for pretty much anything. And in following those guidelines, it gets you to a point of being able to, at a minimum, get a starting point for whatever you're trying to accomplish. These are published, they're free, there's no cost for these. And if you call into like TAC or anything where you have a solution support, you'll be able to get support for the third-party componentry as well as the Cisco stuff. 55. I got 5. You got about 5 minutes, right, Erik?
Yes, that's correct.
All right. Let's hit on some monitoring, visibility, and orchestration, because this is incredibly important to this conversation track, right? So we've got compute, we've got switches, we've got other stuff, obviously. One of the biggest differentiators for us from a compute perspective is Intersight. Intersight gives you monitoring, visibility, compatibility checks, troubleshooting, integration with TAC, power monitoring, management of PDU connectivity. Third-party devices can populate into Intersight, and gives you a full picture of your entire, not only compute, but also your computing environment, which includes your hypervisor, maybe your containers, It's going to include, you can bring network information into this. You can start doing compatibility checks with your OS, your BIOS, and your hardware versioning. So some of those challenges that you get in compute, some of the biggest problems I've ever seen with anybody doing anything in compute is one upgrade of one thing impacts everything. You upgrade your OS, now maybe you have a compatibility challenge with your hypervisor. Maybe you have a BIOS issue. Maybe it's not supported with the version of hard drive you've got populated in that server. This gives you a tool that's going to give you the visibility across all of those components, pieces of your server world to show you compatibility. It's also going to be able to integrate with Cisco TAC, or does integrate with Cisco TAC, and it gives you, if you've ever opened a TAC case, you know that the first thing you're going to have to do is send them logs, right? Well, those logs are already compilable through Intersight. You can open the case through Intersight, and that data will flow to TAC, so your case is already on step 2 before you get to the end of step 1. Nexus Dashboard is the same thing from a network perspective. And network dashboard, Nexus Dashboard flows into Intersight as what we call a target, meaning I'll be able to access Nexus Dashboard information through Intersight. So I'm tying these tools together so you don't have separate. I didn't even make that happen, and it just magically went to the next page. Look at that. So you don't have to necessarily have separate monitoring tools for network and compute. What's coming also at Cisco Live is AI Assistant. You'll see over here on the left. This is essentially integrating an AI assistant into Intersight. So giving you the ability, well, what can I do from an AI perspective with this tool? So a couple of examples, what roles and privileges are available, how do I upgrade, blah, blah, blah. Step-by-step process of integrating AI, more AI, into an already enhanced machine learning platform. And then here's a little bit about Nexus Dashboard. I think this is probably where we're gonna call it after this, Erik.
Yep.
Nexus Dashboard is key to AI deployments, because what we're able to do with Nexus Dashboard, you'll see some of these functions and capabilities over here. We're able to monitor ECN and PFC flows, explicit congestion notification traffic, and we can measure and control through congestion scoring our network connectivity. And we can use this analytics platform to identify areas of the network that need a little bit of care and feeding. Now, this also obviously can be an API. So some customers, especially those customers who are large GPU users, will maybe want to use their own tooling. Well, all of the Nexus switches have custom ASICs, in whether they're cloud scale from the 400 gig and below family or Silicon One with 800 gig and above. Those custom ASICs kick out a lot of telemetry. That telemetry feeds Nexus Dashboard, but also can via API feed other tooling to give really granular performance data from your switching world. I know I got about halfway through the content of what I wanted to cover today, and I apologize that the time wasn't enough. Probably have to do another session on maybe AI security or some other stuff. But thank you for listening in on this. If there's any questions we can answer right now, let's do so. But also use this as a starting point to have a conversation with your Cisco account team. Understand that Cisco has made huge investments across AI, and it starts with the products that we've talked about today from an infrastructure perspective. Erik or Ron, do we have any questions that are?
I think we're good. And I'll just note, like, the cool thing about Cisco is that the answer is somewhere, and the people that have the answers like love these products, and they've spent a lot of time on this. It's interesting to hear them, talk to them. So connect with your account and get in those conversations with those people, and that's for the partners and for customers as well. I mean, it's a good thing to do. Everybody's excited about it. There's a lot of smart people, and a lot of tough decisions have been made in order to build out our product roadmap. So, and there's a lot of stuff that is still coming. So I would say Cisco Live, June 8th through the 12th. Shameless plug there. I will be there. So get out there. If you are going to go out there, let me know. We can catch up. We can have dinner or have a drink or something else. Other than that, I'm going to go ahead and stop the recording, kind of just go into some small announcements.